This is lesson 5.4, which is over indirect proofs or proofs by contradiction. So, for starters, one way to prove that a statement is true is to temporarily assume that we're trying to prove that it is false. So by showing this assumption to be logically impossible, we prove our assumption false and that the original conclusion is true. This is known as an indirect proof. So what we're going to do in these problems is we're going to assume that our prove statement or our conclusion is false we're just going to state whatever the opposite of our proof statement is first. Then we're going to show that that assumption leads to a contradiction. So we're going to show that that has to be false because of what else was given to us. And then for step 3, we're going to point out that the assumption has to be false, so the conclusion must be true. So these are kind of strange proofs, but they can be simple once you start seeing the pattern. So our first one, we are given that 3x plus 5 is greater than 8, and we're asked to prove that x is greater than 1. So our first step is going to be to assume that x is less than or equal to 1, because that is the direct opposite of our prove statement. Okay, then we are going to make a table. So this is x and y, and we're going to pick some numbers. We're going to want to pick numbers that will cause this to be false and one to cause it to be true. So I picked numbers like -1, 0, 1, and 2 because -1, 0, and 1 should all come out to be contradictions and 2 should be true. So if I plug -1 in, I get 3 times -1, which is -3 plus 5, which is 2. And 2 is not greater than 8. So that's our first contradiction. If I plug in 0, I would get that 3 times 0 is 0 plus 5 is 5, and 5 is not greater than 8, so that's another contradiction. We also have to make sure that we have 1 because we want to show that equals to is also false. So if I plug 1 in, I get 3 times 1 plus 5, which is 8, and 8 is not greater than 8. 8 is equal to 8. So this is another contradiction. And if I plug in 2, I get 3 times 2, which is 6, plus 5, which is 11. 11 is greater than 8. So this is enough information to show that our contradiction is, or our assumption led to a contradiction. So that means that x has to be greater than 1. Alright, so these are some exercises that we're going to go through together, and hopefully you will understand those. So first off, they ask you for number 1 and 2 to state the assumption that you would make to start an indirect proof for each statement. So we're just looking for what is your contradiction, what's your step 1. So for this first one, if 2x is greater than 7, then x is greater, or if 2x is greater than 14, then x is greater than 7. So the opposite of x being greater than 7 is going to be for x to be less than or equal to 7. So for number 2, they say that for all real numbers, if a plus b is greater than c, then a is greater than c minus b. So we're going to want to figure out what the opposite of a is greater than c minus b is. So that's going to be that a is less than or equal to c minus b. So pretty much on these, you're just going to be changing this sign for the most part. So this is an indirect proof that they have started for us, and we're just going to be filling in what the blank is. blanks are. And this is a number theory proof, so it's not quite as simple as the one that we did as an example. So first off, we have to assume the opposite of what we're asked to prove. And since we are given that n is an integer and n squared is even, we want to show that n is even. So first off, an integer is positive and negative numbers that are not fractions. So none of our problems will be fractions, either positive or negative. And then, so if we're asked to prove that n is even, we're going to assume the opposite of that, which is that n is odd. So if n can be expressed as, then n can be expressed as 2a plus 1, which is probably not a notation that you're used to, but if you think about all odd numbers, you can take 2 times a number and then add 1 to it, and you're going to get an odd number. So this is actually by definition of an odd number. So that means that n squared is just going to be, I'm just going to plug this information, I'm going to plug this in for n. So that means that n squared equals 2a plus 1 squared by substitution. And if I'm going to multiply, then I'm going to multiply this out, which you want to make sure that you correctly FOIL this. Don't just distribute the square. You'll get 4a squared plus 2a plus 2a equals 1, or plus 1. And then you're going to simplify or combine like terms and get that 4 times 2a plus 4a plus 1. Now if I pull out a 2, I end up with 2 plus, or times 2a squared plus 2a plus 1, and ultimately this is just another number, and it can be any number, but when I multiply it by 2 and then add 1, it just ends up being an odd number. So this is where I factored out my 2. So that means that this has to be an odd number, and this contradicts your given that n squared is even, so that means your assumption must be false. Therefore, n is even. So indirect proofs with geometry. Write an indirect proof in geometry. You assume that the conclusion is false, then you show that the assumption leads to a contradiction. The contradiction shows that the conclusion cannot be false. So we're pretty much going to use the exact same steps for these. They're just going to be geometry problems. So this first one says you're given that the measure of angle C equals 100. You're asked to prove that angle A cannot be a right angle. So first we have to assume that our proof is false. So we're going to first assume that angle A is a right triangle, or is a right angle. So if this is a triangle, that means that my angles have to add up to 180 by the triangle sum theorem. So then I'm going to substitute in this information. So if A is a right angle, that means that this is 90 plus B plus 100 equals 180. I just substituted there. Here I substituted again, I combined like terms, simplified, and I got that 190 plus angle B equals 180. And then I subtracted the 190 from both sides, and I get that angle B equals 10, or equals negative 10. But step 3 would be that B cannot be a negative number because numbers, or angles, cannot be negative. So therefore our assumption has to be false. That's it. Alright, so some more practice. State the assumption that you would need to make to start an indirect proof for each statement. So if the measure of angle A equals 90, then the measure of angle B equals 45. So the opposite of the measure of angle B equaling 45, it would be that the measure of angle B does not equal 45. It would be that it equals anything else. So if AV is not congruent to VE, then triangle AVE is not isosceles. So that means, so what we're going to do is we're going to assume the opposite, which would mean that a triangle AVE is isosceles. So here's another indirect proof, geometry one. I think it'll be easier for you because it's more familiar than the last one we did. So first, we are given that angle 1 and angle 2 are congruent. They marked that in our picture. And they said that DG is not congruent to FG. So these are not congruent. And we are asked to prove that angle DE, or segment DE, is not congruent to FE. So first we're going to assume that DE is congruent to FE. Okay. Now this side here is going to be congruent to itself. And anytime something is congruent to itself, it's congruent to itself because it is reflexive. So triangle EDG has to be congruent to triangle EFG, because if I were to mark this here, that means that these two triangles have to be congruent by side, angle, side. And if these two triangles are congruent, that means that DG would be congruent to FE, because corresponding parts of congruent triangles are congruent. So this would contradict the given information, so the assumption must be false. Therefore, DE is not congruent to FE. And that's it.